Hi students, welcome to this class, class number 6. In previous class, we are discussing about the lanthanide contraction. What is the meaning of lanthanide contraction? Lanthanide contraction means in lanthanides from left to right, atomic radius is or ionic radius is steadily decreases. The decrease is called as a contraction. That decrease is observed in lanthanides. So, the type of contraction, that means decrease or decrement, is called as a lanthanide contraction. This lanthanide contraction is due to the poor shielding effect and the differentiating electron is enter into same sublevel. The sublevel is 4f and poor shielding effect. That is the reason. At the same time, f orbital shape also is the one of the reason. F orbital shape is the peculiar shape. Okay, this is the lanthanide contraction, and then some consequences arising due to the lanthanide contraction. That consequences are we are discussing. Consequences is first consequence, atomic radius. Sir, what is atomic radius? Is the periodic property. In this property, in groups from top to bottom, atomic radius is increases. In observed in transitional series 3D, 4D, 5D, 6D, scandium, titanium, vanadium, chromium, manganese, like 4D starting with yttrium, zirconium, niobium, molybdenum, technetium. The same time 5D series, lanthanum, hafnium, tantalum, tungsten, rhenium. In this, after lanthanum atomic number is 57, hafnium atomic number is 72. In between the 14 elements is placed, that differentiating electron is enter into the 4f shell. This shell is affected by the contraction, lanthanide contraction we are discussing. So, in this from top to bottom 3D, 4D, 5D, 6D. 3D has the only 4 shells, then 4D having the 5 shells because of this is placed into the 5th period, this is placed into a 4th period. So, atomic radius is 4D is higher than 3D, comparatively 5D is higher than 4D, but in this case zirconium, hafnium both are having the similar atomic radius. At the same time, niobium, tantalum both are having also similar atomic radius. At the same time, molybdenum, tungsten both are having also similar atomic radius. That means 4D elements having 4D and 5D elements both are having the similar atomic radius. Generally 5D having the large atomic radius comparatively 4D, but similar atomic radius is attained because the lanthanide contraction is affected into hafnium, tantalum, tungsten elements also. So, the generally contraction, that means lanthanide contraction means decrease the atomic radius affected by hafnium, tantalum, tungsten. These elements are also decrease the atomic radius. These three are similar to the very similar to the zirconium, niobium, molybdenum. So, 4D and 5D elements having the similar atomic radius due to the lanthanide contraction. This is the first consequence, and then second consequence, 4D and 5D. Second consequence is the IE values. Generally in groups from top to bottom, ionization energy values are decreases because atomic radius is increases, nuclear charges decreases. But in this case 3D from top to bottom, 3D having the ionization energies, 4D having also ionization energies, 3D having the higher ionization energies than 4D because atomic radius will be increases. Then after 4D having also ionization energies, 5D also having the ionization energies. Generally 4d having the higher ionization energies comparatively 5d, but due to the lanthanide contraction 5d having the higher ionization energies than 4d values due to lanthanide contraction. This is a second consequence of the lanthanide contraction. And then third one, basic nature. Generally lanthanides, cerium to lutetium, these elements are react with oxygen to formation of a oxides and react with water to formation of a hydroxides generally. So this indication of lanthanides, indication of any one metal Ln. Ln is combined with water or react with water to formation of a OH. Common oxidation state is +3, so 3 elements are 3 ligands are combined. So lanthanide hydroxides or oxygen combined lanthanide oxides. This lanthanum mean metals, these are the 4F. Lanthanides are the group of elements. In any group from top to bottom atomic radius will be increases. Atomic radius increases means the metallic nature is also increases. Metallic nature is increases means the basic nature also increases. But in this case lanthanides, these are arranged into period from bottom of the periodic table. So this atomic radius is decreases. Atomic radius is decreases means the metallic nature is also decreases. Metallic nature is decreases means the basic nature also decreases. That means from lanthanum to lutetium of hydroxides or oxides, the basic nature is decreases due to lanthanide contraction. This is the third consequence. And then fourth consequence. Fourth consequence is the due to the lanthanide contraction from left to right in lanthanides, from cerium to lutetium, all are having the similar size, generally slightly decrease the atomic radius. So total all are having the similar atomic radius. The similar atomic radius of the all lanthanides are taken into a group. Then these elements, that means lanthanide metal atoms, all are having the same size. So cannot easily separate the mixture of the lanthanides. So due to similar size due to the similar size because of lanthanide contraction. So this type of metals, same size of the metals, all are separated very difficult. So this difficultiness is arising into the ion exchange method can only separate the mixture of the lanthanides are very easily separated. Okay, this is the another consequence of the lanthanide contraction. Okay, lanthanides are also exhibits different color salts. Lanthanides are formation of different color salts. As similarly d block elements, transition elements exhibits color due to the DD transition in the presence of the ligands. Like lanthanides also exhibits colors like FF transition. In this F block elements, FF transition is attained due to the ligand attacking into the metal atoms, that means lanthanides. Then these are also exhibits different colors due to the FF transition. For example, neodymium +3, at the same time erbium +3, both are having exhibits same color, that color is the pink. At the same time samarium +3, dysprosium +3, both are also exhibits yellow color. Sir, why both ions are exhibits same color, at the same time both are exhibits same color? Why? Because of neodymium is having the F3 electronic configuration, at the same time erbium it's having the F11 electronic configuration. At the same time samarium it's having the F5 electronic configuration. At the same time dysprosium F9 electronic configuration, 9, 5, 11, 3. These are the electrons, number of electrons present in F orbital. For example, neodymium 3 electrons, in f orbital split up into 7 degenerated orbitals 1, 2, 3, 4, 5, 6, 7. In this 1, 2, 3, only 3 unpaired electrons, then neodymium exhibits pink color. Otherwise, erbium plus 3 also exhibits pink color, but this electronic configuration is F11. Other electronic configuration f orbital, it's contain 7 degenerated orbitals 1, 2, 3, 4, 5, 6, 7 having 11 electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's contain also 3 unpaired electrons. At the same time, neodymium also 3 unpaired electrons. So, unpaired number of unpaired electrons equal, then exhibits the same color of any of the lanthanide elements. For example, samarium plus 3, these are having the f electrons are only 5. At the same time, dysprosium, these are also having f electrons are 9. For example, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, it's having the 5 unpaired electrons. But in this dysprosium, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's having the 1, 2, 3, 4, 5, 5 unpaired electrons. It's having also 5 unpaired electrons. So, both ions are exhibits same color, yellow color. Both are exhibits pink color due to the FF transition. So, these are exhibits colors also, and these are exhibits maximum paramagnetism. And then these lanthanides, formation of alloys, easily formation of alloys because of small atomic radius. So, these are easily formation of alloys. The example of alloy is first one, any lanthanide metal. Alloy means metals, one or more than two metals are mixed or combined to formation of a homogeneous mixture. This concept we will discuss previous classes. Okay. So, in transition elements. So, lanthanides are also forms alloys. For example of the alloy is any lanthanide, cerium, lanthanum, like any lanthanide is 90% is combined with 5% of iron. Any one metal or two metals of the lanthanides 90% and iron is combined with 5% and remaining percent of the carbon, sulfur, calcium, aluminum, like small elements of traces of the elements are combined to formation of a alloy. Formation of a alloy. This alloy is called as a mixed metal. This formation of metal is called as a mixed metal. This mixed metal means in this having 90% lanthanides and remaining 5% of iron and its small traces of the carbon, sulfur, calcium, like this alloy is called mixed metal. It is used in preparation or manufacturing of the bullets and flints of the lighter, and bullets. It is used as well as in lanthanides. Uses of the lanthanides, the lanthanide oxides are used into petroleum industries, used as a catalyst. This is the lanthanides. These lanthanides are also called as a inner transition elements. Okay, and then actinides. What is the meaning of actinides? Actinides means the differentiating electron is enter into 5f sublevel. That elements are called as a actinides. The general electronic configuration of the actinides is (5f) 1 to 14, 6d 0 or 1 and 7s2, and the elements are the actinides from starting with the actinides are starting with actinium, actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, lawrencium. These are the actinides. These are the electronic configurations follows the lanthanides also. Similar the electronic configuration of the lanthanides. Okay. So, these elements actinium, thorium, protactinium, uranium, these are the natural elements, and remaining all are the synthetic elements. Synthetic elements means man-made elements. Then after uranium, that elements from neptunium to lawrencium, these elements are called transuranic elements. Okay. That means after uranium elements are called as a transuranic elements. And actinium, thorium, protactinium and uranium, these four are the natural elements. And then all are the radioactive elements. That means all elements are emit the radiation. So, all elements are the radioactive elements. Okay. Then these are also, that means this is the 5F series, these are called as a actinides. These are also placed in the periodic table, bottom of the periodic table, the bottom of the lanthanides. So, lanthanides from left to right atomic radius will be decreases, that is called lanthanide contraction, we will discuss. Okay. Same as it is this actinium, from actinium, that means thorium to lawrencium, these elements are also arranged into from left to right in periodic level, bottom of the periodic table. So, these elements having also decrease the atomic radius from left to right, from thorium to lawrencium, the decrease is called actinide contraction. This is called actinide contraction. Okay. Then these are all are the hard metals, all are the hard metals. These are having the high melting points and boiling points, high melting points and boiling points, and these elements all are having the high densities. And lanthanides and actinides both are having the low ionization energy, because of inner orbitals are more, inner shells are more, so nuclear charge is decreases. So, loosely bound the electrons is there, so ionization energies are very less. Comparatively another elements in periodic table, lanthanides and actinides having the less ionization energies, and these elements are very strong metals and formation of alloys. At the same time, these elements formation, easily formation of complex compounds also. Then lanthanides, lanthanides are less formation of the complex compounds, but actinides are easily formation of the complex compounds. At the same time, these elements react with oxygen to formation of a oxocations. For example, UO2 plus 2, PuO2 plus, like that. Cation formed on the surface of the oxygen. The type of oxides are called as a oxocations. Uranium and plutonium, neptunium, these all are exhibits a formation of oxocations, and these elements all are exhibits different variable oxidation states, like lanthanides, like transition elements. These elements generally 4F shell, that means lanthanides exhibits plus 2, plus 3, plus 4 oxidation state only. But in actinides, neptunium, plutonium both are exhibits plus 7 oxidation state, and then these all are exhibits 6d1 1 electron and 7s2 totally 3 electron, easily lose of 3 electron. Then all our elements can shows common oxidation state is plus 3, common oxidation state is plus 3, but these elements exhibits plus 3 to plus 7 oxidation state. In these elements, neptunium and plutonium both are exhibits plus 7 oxidation state. Then these elements are exhibits paramagnetism. because these all are having the unpaired electrons. So these elements all are exhibits paramagnetism, and these are all are having the unpaired electrons. So these are exhibits at different colors. This is the actinides. And then uses of the actinides in this: uranium, the very important element in this series. Uranium is used in nuclear fuel, used as a nuclear reactors, as a nuclear fuel. At the same time, uranium forms number of salts. The uranium salts are used in medicinal industries, textile industries, at the same time glass industries also. Then plutonium, it is also very important element. This plutonium is used as a atomic nuclear reactors, at the same time atomic bombs like that. Okay, this is the actinides. So we are discussing in this class lanthanide contraction and consequences, and then actinides, the properties of the actinides. Okay, next lesson is the complex compounds. The next lesson is coordination compounds or coordination complexes. Sir, what is the meaning of the coordination compounds or coordination complexes? In the transition metals or inner transition metals, any metals are combined with ligands. Sir, what is the meaning of ligand? Ligand means can donate a pair of electrons. So any ligand, number of ligands are combined with metal atom. That means metal means from transitional elements or inner transitional elements. This metal having the empty d or f orbitals, then this metal is combined with ligand. These ligands can donate a pair of electrons. Donate a pair of electrons to formation of a bonds. That bonds are called as a day2 bonds or coordinate covalent bonds. So in this metal ligands combined, then formation of a compound is called as a complex, or compound is called as a coordinate covalent compound or coordinate covalent complexes, because in these compounds having all are the coordinate covalent bond are built up with the coordinate covalent bonds. So this type of complexes are called as a coordinate covalent complexes or coordinate covalent compounds. First of all, in this lesson, some terms, important terms we will discuss. Okay, first of all, central metal atom or central metal ion. In any complex, one type of complex, the metal atom or ion to which a fixed number of atoms or groups, that means fixed number of atoms or groups are bonded to the metal atom in a fixed and in a special geometrical arrangement around in the metal atom, that is called central metal atom. Any complex metal atom or ion to which bonded to the number of a fixed number of atoms or ions or groups around it, at the same time at a definite geometrical shape. The type of metal is called as a central metal, is called as a central metal atom or central metal ion. Then for example, complex CONH3 6 times. In this complex, the central metal atom is cobalt. This cobalt is combined with fixed number of ligands. In this 6 ligands, NH3, 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 atom or ion to which bonded a fixed number of ions or groups in a definite geometrical arrangement around in it. This is the octahedral shape. The geometry is the octahedral, and the arranged around the bonded to the these 6 ligands or 6 atoms or 6 molecules bonded to the central metal atom. This is called central metal atom. At the same time, example of FeCN6 minus 4. In this, 6 cyanide ions are combined with Fe. Iron is the, in this complex, iron is the central metal atom or central metal ion. Next term is ligand. What is the meaning of ligand? Ligand means atom or ion or group that donate a pair of electrons, to central metal atom to formation of a coordinate covalent bond. The type of groups or atoms or molecules or substances are called as a ligand. What is the meaning of ligand? Any substance or molecule or group or atom that can donate a pair of electrons to the central metal atom, then formation of a coordinate covalent bond. The type of substances or molecules or atoms or ions are called as a ligands. These ligands are classified into 3 types. They are, first one, positive ligands, and second one, negative ligands, and third one, neutral ligands. Positive ligands, example NO plus and NO2 plus. They are having the charge is positive, but they are donate lone pair of electrons to the central metal atom and the formation of the coordinate covalent bonds with central metal atom. At the same time, negative ligands, that means elements, the atoms or ions having the negative charge like Cn minus, OH minus, COO minus, oxalate ion. These are having the negative charged species. This negative charge means more electron density, then it can easily donate a pair of electrons to formation of a coordinate covalent bond with central metal atom. This type of ligands are called as a negative ligands. And then neutral ligands, ammonia, NH3, at the same time water. Both are neutral ligands. These are no positive and no negative charges, but nitrogen having the one lone pair of electron can easily donate a pair of electron to formation of a coordinate covalent bond. At the same time, water. This is also acts as a ligand, neutral ligand. At the same time, in these ligands, any type of ligand, a ligand having only one lone pair of electron can donate only one lone pair of electron. The type of ligands are called as a monodentate ligands. At the same time, any substances, ions, molecules or atoms having the donate 2 lone pairs, that means atom having the or molecule or ion having the 2 lone pairs, donate the 2 lone pairs and the formation of the 2 coordinate covalent bonds with a central metal atom. That type of ligands are called as a bidentate ligand. At the same time, 3 lone pairs, substances which are donate 3 lone pairs, then formation of a coordinate covalent bonds with central metal atom, they are called as a tridentate ligand. Then 4 lone pairs donate tetradentate, 5 lone pairs are donate pentadentate, 6 lone pairs are donate hexadentate. Okay. Sometimes same compound can donate either 5 lone pairs or 6 lone pairs. So, either 5 lone pairs or 6 lone pairs can donate a substance, that substance or that ligand is called as a flexidentate ligand. The dentate ligand is called flexidentate ligand. For example, EDTA, ethylene diamine tetraestic acid. The structure of the EDTA is CH2, CH2, N, N. Ethylene diamine tetraacetate. This compound having the 1, 2, 3, 4, 5, 6. 6 lone pairs can easily donate formation of a day 2 bonds with central metal atom. So it is called polydentate ligand, like a flexidentate ligand also. So any compound can donate a pair, single pair is called monodentate ligand, 2 pairs donate is called bidentate ligand, 3 pairs donate tridentate ligand, 4 pairs donate tetradentate ligand, 5 pairs donate pentadentate ligand, 6 pairs donate hexadentate ligand. More than 6 polydentate ligands are called. Okay. Then remaining terms we will discuss next class. Okay.